Welcome to your first ed puzzle. Here's our virtual classroom getting ready for AB Calculus. It's going to be a great year. It'll be unique, but it'll be a great year. For those of you returning, this is the calculator that you should already have, one of these two. And for those of you that are new to the John Cooper School, welcome. And this is the calculator that you should get, either one of these. The blue one is the upgraded one, and new is always better, but you might want to check the Spirit store and see if they have some of them in stock. But the important thing is make sure that it says CAS. Don't go with a cheaper version that doesn't have the CAS, because we will definitely be using that in calculus this year. There are several platforms we'll be using throughout the year. First of all, our class webpage, which we'll go through later. We went through it in class. AP Classroom, which we will get to later. Ed Puzzle, which this is. Delta Math, which you may be familiar with from pre-cal. And then, as others are necessary, we'll add those as well. The Delta Math website is ready for you to set up. My teacher code is 638389, and you need to make sure that you sign up in the class period that you're in, and you use your last name and first name so that I'll know who you are, since I don't know who all of you are yet. And you will have a Delta Math assignment tonight, so make sure that you go ahead and sign up. So as a way to get familiar with Ed Puzzle, we're going to go ahead and do a little bit of math, sneak a little bit of math in on you here. So our first topic in calculus is going to be limits. And I think you might be familiar with the limit notation. The limit as x approaches 2. The two men you see here are the founders of calculus, Isaac Newton and Gottfried Leibniz. And they were pretty much developing calculus. The two men that you see here are considered to be the founders of calculus, Isaac Newton and Gottfried Leibniz. They were developing calculus about at the same time independently, and there are stories that one would claim that they discovered it and the other would claim that he discovered it, but we give credit to both of them, and we can thank them for everything that we know. Well, not everything that we know, but for some of the things we know. So one of the points of this Ed Puzzle is to just get used to Ed Puzzle, but I figured I'd go ahead and sneak a little bit of math in here. Our first topic that we'll be discussing in calculus this year is limits. I know that some of you are familiar with limits and the limit notation. Here is that limit notation right here. The limit as x approaches 2 of f of x is what? And what a limit means is, as I'm getting closer to this x value of 2, from both the left side and the right side, what is the y value trying to be? Whether it gets there or not, that's what we're looking for. So the limit as x approaches 2 of this function is 1. In this first example, the actual function value at 2 is also 1. But if you look at the second example, you can see that as I'm approaching 2, the x value of 2 from the left and the right, there is no y value. But the y value that the graph is trying to approach is still 1. So the limit is 1, but the function value does not exist. In the third example, as I'm approaching the x value of 2 from the left and the right, there is no function value. The function value is actually way up here. But that's not what a limit is. The limit is, as you're approaching that x value of 2, what is the y value approaching? And that would be 1. But in this case, the function value would be 2. Okay, so let's use this example here. This is a much more complicated graph, and there's lots of different limits and function values. Make sure that you pay attention to the difference between something that's a limit and something that's a function value. So number 1, the limit as x approaches 1. So here's the x value of 1. Get on the graph close to 1 and approach it from both sides. And what is the y value trying to be? It's not, because there's nothing there, but the y value would like to be -1. Number 2, f of -3. Now that's a function value, so you go to -3 and you look for the actual point that's there, which is 0. Number 3, as x approaches 2, so I'm going to this x value of 2 from both the left side and the right side on the graph. I'm not looking at that point right there. I'm looking from the left and the right of 2. And what is the y value trying to be? 2. But on number 4, I want the function value at 2. So this time I do want that point, and that answer would be 3. So there's definitely a difference between a limit and a function value. Sometimes. Sometimes the function value can be the same as the limit. The next one, I want f of 1. Now think about it. Do you want the function value or where the graph is trying to go? You want the function value. So we're looking when x is 1, what is the function value? And I don't see anything on the graph when x is 1. I don't see any points. So that would be does not exist. Number 6, f of -2. So I'm going to the x value of -2, and I'm looking for where there is actually a point on the graph, so I don't need to be going from the left and the right. This is what is the y value there, and the answer is 2. The next one, as x is approaching 0. So this one's a limit, so I need to be coming from the left and the right on the graph, and it looks like my answer would be -2. And the last one, as x is approaching -3. So this one's a limit, so I need to be going from the left and the right of -3. And it's where the graph is trying to go, not what the function value is. So that would be 1. So here's a new graph, and here's one for you to try. Look at this graph and see if you can answer 12 through 19 and record your answer in the Edpuzzle. You may need to pause the video so that you can get that done. Okay, so now check your answers against these. And I made a mistake on one on purpose to see if you could catch the errors. So look, compare these closely to yours and find the one that, if you got everything right, is different than mine. And if you chose this one, this is the one that is incorrect, because f of 3, there is no point there. So that should be does not exist. So hopefully you did great. That's the end of the video. Great job, you did it. We'll have lots and lots of more practice, and I'll see you on Monday. Bye.